Welcome to the halls of the Emporium. This channel and its official site are intended to be a collaborative project focused on the calculation of feats in fiction and the translation of related material, as well as a new framework for power scaling, one that will be a new phase in the legacy of power scaling. This video will be the first in a series of videos covering the manga by Eiichiro Oda known as One Piece. The general format of the series and others like it that will also be coming to this channel is covering the feats within the arcs of each story and using comparative analysis to surmise how strong the characters within the story are. Sometimes there will be multiple arcs per video if the arcs aren't long enough for a standalone video. We are only going to be going over the plot aspect of each arcs whenever it is necessary, as these video series are not a market substitute for the story it is covering. The main protagonist of One Piece is Monkey D. Luffy, and our main through line in which we can compare characters against, as he will be in the majority of the story and fights many characters. In Volume 1, Romance Dawn, Luffy fights Alvida. Alvida is able to destroy a small wooden building with one throw of her club. To get the size of this building, we must find a way to compare it to something that is a known size. The character Kobe is 167 centimeters tall, and he takes up 457 pixels of the panel. 167 centimeters divided by 457 pixels equals 0.3654 centimeters per pixel, meaning each pixel of the panel is 0.3654 centimeters in length. The thickness of the wood is 25 pixels or 9.135 centimeters, and the length of Hepiko's face, the guy on the right of the panel, is 113.2 pixels or 41.2663 centimeters. Hepiko's face in a previous panel was 70 pixels, meaning the centimeters per pixel of this panel is 41.2663 centimeters divided by 70 pixels, or 0.5909 centimeters per pixel, and the height of the door is 404 pixels, meaning it is 238.7426 centimeters tall. The door height, 238.7426 centimeters. In the panel where we see the most full shot of the building is 127 pixels in height, giving us a centimeters per pixel of 1.8798. The full height of the building is 221 pixels, meaning the full height is 415.4498 centimeters. The left corner and the right corner of the building are both the same height of 415.4498 centimeters, but are different pixel lengths, 244 and 150 pixels respectively. When compared to the height of the total panel of 944 pixels, the left corner is 24.6963% and the right corner is 15.1821% of the height of the panel. The generally accepted viewing angle of the human eye within the power scaling community is 70 degrees, 24.6963%, and 15.1821% of 70 degrees is 17.2874 degrees and 10.6275 degrees. A height of 415.4498 centimeters is 17.2874 degrees and 10.6275 degrees at a distance of 1,366.4632 centimeters and 2,233.3726 centimeters. These two lengths and the length of the building make a triangle. To get the angle between the two sides, we know the length of, we can take the length of the pixel between the two sides, 153 pixels, and compare it to the length of pixels of the total length of the panel, which is 1,589 pixels, which equals 9.6286%. And 9.6286% of 70 degrees is 6.74 degrees, and a triangle of 1,366.4632 centimeters, 2,233.3726 centimeters, and 6.74 degrees corresponding angle has a length of its third side of 890.9065 centimeters. Taking the building as a square, we have 890.9065 centimeters by 890.9065 centimeters by 415.4498 centimeters, and 9.135 centimeters thick, which gives us a volume of 2,077, 5018.8900 cubic centimeters. The level of destruction of the building is violent fragmentation. The value for the violent fragmentation of wood is 6.6879 joules per cubic centimeter. 2,077, 5018.8900 multiplied by 6.6879 equals 138,941,248.8347 joules. or 33.2077 kilograms of TNT or small building level. This is where the most common power scaling systems would stop. Unlike the most common power scaling systems who are only concerned with the total energy output, we here at the Emporium are also concerned with the intensity of the energy output. To clear up the terms, the total energy output is what we call destructive capacity, and the intensity of the energy output is what we call attack potency. The attack potency of an attack is a function of the initial area of the thing emitting the attack. The attack specifically was a spinning projectile attack from Alvida's club. Alvida herself is 198 centimeters tall, and in the panel where we can best see the club, Alvida is 631 pixels tall, giving us 0.31378 centimeters per px. The club is 450 px by 133 px, giving us 141.2044 centimeters by 41.7337 centimeters, or 5,850.6207 square centimeters, 138,941,248.8347 joules, / 5,850.6207 square centimeters equals 23,748.1210899 newtons per centimeter squared. Joules break down to newtons / meters, which is why without the third meter from cm⁻3, the joules are just newtons. Newtons per area is the definition of pressure which is measured in pascals. 1 net 1 per centimeter squared is equal to 10,000 pascals, so 23,748.1210899 newtons per square centimeter equals 237,481,210.899 pascals or 237 megapascals, which is greater than the force/pressure needed to turn rock to dust and split steel. How our attack potency chart works is each level corresponds to the amount an attack could destroy, which represent the quantity of newtons on that level per 1 square centimeter of the attack. So if an attack has building level attack potency, then it can destroy a building with only the force from 1 square centimeter of the attack. To convert from the commonly used attack potency / destructive capacity chart to our attack potency chart, you just have to take the total joules of a level / the volume that level represents. Tracking down the volume used for the first couple of levels of the attack potency / destructive capacity chart was a little hard, but after that what is just used is to get the value for the level was the total value of the thing named in the level times the joules per centimeter. So all we have to do is multiply 10,000 for pascals. This is all a little too complicated just to remember, so the conversions have all been done and listed on the Emporium website. This all has been said just to explain why 237 megapascals is only wall level attack potency. Each centimeter of the club attack has the ability to destroy a wall, not the attack can only destroy a wall. Before the attack potencies get to the extreme level, which starts around small building level attack potency where no substance in our universe could withstand, it is more useful to describe wall level and below in what it could destroy and at what level of destruction: rock, iron, steel, etc., etc. Alvida's fist is 52.2 px by 34.4 px or 16.3793 centimeters by 10.794 centimeters, which equals 176.7983 centimeters squared. And as her fist does not explode or is damaged when she exerts 138,941,248.8347 newton force, we can say her body can take and her fist can dish out the level of force of 138,941,248.8347 newtons per 176.7983 centimeters squared equals 785. 874.34853 n/cm⁻2 or 7,858.7434 megapascals or 7.8587 gigapascals, greater than the force needed to liquefy iron and steel. This was a casual attack from Alvida aimed at her own crew, so it is nowhere near an upper limit of her capabilities. What is an upper limit for her, though, is a single gum pistol from our protagonist, comfortable placing Luffy's lower bound at the 7.8587 gigapascals. Wall level. There are other things that happen within Volume 1 of One Piece that are power scaling related that are debatable whether they affect the scaling of the series. When such things occur, there will be a consideration section in the sibling article to these videos and will only be mentioned in videos if it is vital to do so. Buggy D-Clown has a cannonball he calls the Buggy Ball that wipes out a number of buildings. Like the last calc, we will have to find something with a known size and work our way up from there. Nami has a height of 169 centimeters and is 359 px tall, which equals 0.47075 centimeters per px. The cannon barrel is 363 px times 0.47075 centimeters per px equals 170.883 centimeters. Cannon barrel 170.883 centimeters and is 50.2 px equals 3.40404 centimeters per px. Depth of drinker pub 836.9 px x 3.40404 centimeters per px equals 2,848.8444 centimeters. Railing height 45 px x 3.404 centimeters per px equals 153.1819 centimeters. Wall thickness 31 px x 3.4040 centimeters per px equals 105.525 centimeters. Railing height 153.1819 centimeters / 13 px equals 11.7832 centimeters per drinker pub height 500 px x 11.7832 centimeters per px equals 5,891.6145 centimeters. Drinker pub length 729 px x 11.7832 centimeters per px equals 8,589.9740 centimeters. Parameters of drinker pub. Concrete walls and ceiling, 105.525 cm thick. Wood exterior and interior, 8,589.9740 centimeters by 2,848.8444 centimeters by 5,891.6145 centimeters equals a volume of 2,589,695,578.7660 cubic centimeters of concrete times. Violent fragmentation of concrete 20J / cubic centimeters equals 51, 793, 911, 575.32016 J, or 12.379 tons of TNT city block level. The buggy ball also destroys buildings that are a story taller than the drinker's pub, likely making them larger than it, but for simplicity, and to have a conservative estimate of the feet, it will just be multiplied by the number of buildings destroyed at once, which is 7. The 7th building's remains can be seen in the panel that show the aftermath, with the 7th building being green, it being obscured by the explosion in the first panel. 51,793,911,575.32016 JX7 equals 362, 557, 381, 027.2411 J, or 86.653 tons of TNT city block level. Barrel / buggy ball diameter 103 px x 0.47075 centimeters per px equals 48.48746 centimeters. A circle of 48.48746 centimeters in diameter has an area of 1846.4976 centimeters squared. 362,557,381,027.241 newtons per 1846.4976 centimeters squared equals 196,348,687.9307 newtons per centimeters squared, or 1,960,000. 3,486,879,307 pascals, or 1.9634 terapascals. 9.34633x the newtons per centimeter squared need to atomize diamond. 27.1138x the newtons per centimeter squared needed to atomize a human body. And in our attack potency chart, wall level 2.096 terapascals is small building level. Buggy seems to take some damage from the buggy ball, at least enough so that he is stunned long enough to let an injured Zorro carrying Luffy to get away, putting the buggy ball high relative to Buggy. Buggy and Luffy's fight continues in Volume 3. Buggy goes low to just relative to Luffy, placing the ranking as Buggy Ball 1.9634 terapascals. Buggy Luffy, meaning Luffy and Buggy are at least 1.9634 terapascals wall level in durability and attack potency. You can find more content for Volume 3 and extra content for Volume 4 on our website. That being said, in Volume 4 the villain Captain Kuro is able to move faster than his underlings can see. Captain Kuro is 207 centimeters or 165 px tall, 165/285 px equals 0.5789. 57.89% of 70 degrees is 40.5263 degrees. 207 centimeters is 40.5263 degrees at 280.35 centimeters, which is the distance he moved. Now for the time frame, Kuro's claw gloves are 119/285 px equals 41.75438596%. 41.75438596% of 70 degrees is 29.228070172 degrees. The human eye can see up to 1 arc minute, which is 0.017 degrees. The minimum length of the bag that are used to carry the Kuro's claw gloves is the length of the claw gloves 119 px or 29.228070172 degrees. And as the bag was frozen in the air, the minimum change in distance downward from gravity is the 0.017 degrees. And to get a meaningful metric, we can just reverse the formula 29.22807.0172 degrees plus 0.017 degrees equals 29.245070172. 29.245070172 degrees of 70 degrees is 119.06921425595. 119.06921425595 px. 119 px equals 0.06921425595. 0.06921425595 px x 1.2545 centimeters per px equals 0.08682928885 centimeters. Captain Kuro moved with his stealth foot technique 2.8035 m in 0.013307 seconds equals 210.6785 meters per second or Mach 0.6122, which is subsonic plus. In the SBS of Volume 7, Oda says he thinks Kuro's movement would be around 100 meters in 5 or 4 seconds. Well, in the SBS of Vol 42, during a part of the series where another high-speed movement technique is introduced, he says they are about the same in speed, and Kuro higher level version of his technique is even faster. Well, the Vol 42 technique is that speed and can be controlled, which at that point in the series the characters are scaling to the speed of lightning, which is significantly faster than Mach 210, let alone 210 meters per second. Luffy and Kuro are both able to dodge each other's attack speed, and Luffy seems not to be able to keep up with Kuro's stealth foot speed. Then Luffy and Kuro start to fight seriously. Kuro is able to damage Luffy with his somewhat pointy shoe, as Luffy's gum fruit nullifies blunt damage, which explains why it can do damage to him, and as it is an orders of magnitude smaller in area like a blade, means Kuro does scale to at least Luffy's MQP, minimum quantifiable power, of 1.9634 terapascals wall level. After that, Luffy is able to track the stealth foot, which could just be a prediction/battle IQ feat rather than a perception or speed feat. Looking into the raw Japanese, it says, あいつ、抜き足の速さについて行きやがった. It does not say he tracked the stealth foot, but directly says it's the stealth foot speed, he. The stealth foot speed, able to reach what? Or what? He's able to reach the speed of the stealth foot. This means a high end but not maximum for Luffy is the speed of the stealth foot, which means we can go with 25 meters per second or the speed of lightning, but as we didn't do the work of calculating for nothing, we are going to be sticking with our minimum speed for the stealth foot of 210 meters per second until we get more firm speed scaling to the speed of lightning. Thank you for watching. For further information, you can go to acolytecephalog.wixsite.com/emporium.